Beautiful work. I see a lot of really good work. I see a lot of really good attempts. I see a lot of blank pages, especially when we were giggling. I'm just saying. Maybe they will start being, I'll just hand somebody an iPad. Figure it out. I can always do that. Just make you do it. What were our thoughts on this? How would we solve this one? Be more specific. There's definitely an option where you can do it with square roots. They're totally fine. Just need more details. In order for me to be able to square root, I can't just do it right here because this minus sign in the middle throws a wrench in our plans. But I could absolutely do that if I was to add 100 to both sides to get that x squared by itself. We absolutely can do this with square roots, giving us an x squared equals 100. Because if I do the square root, what number when squared is 100? And what other number when squared is 100? Negative 10. So this would be positive or negative 10. Absolutely valid way to do that. Whenever we are square rooting both sides of an equation, because we chose to square root it, we need to add a plus or minus. Because it could be that it was positive 10, it could be negative 10. We're getting our two roots, our two solutions. The other option we could take on this one, so this one, I'll call this one option A. This one option B, I could notice that x squared minus 100, x squared is a perfect square and 100 is a perfect square. So I could rewrite this as my x squared minus 10 squared equals 0 and put it through my difference of squares where we have our x plus 10, x minus 10. Also valid, and in which case we're getting our exact same two solutions by setting each of our factors equal to 0. X plus 10 equals 0. And we get a solution at negative 10. And our x minus 10 equals 0. We'll have a solution at x equals positive 10. So either way you do this, you're getting the exact same answers of positive 10 and negative 10. Both are 100% equally valid. So if you spotted this, great, perfect. If you spotted this, awesome. Works totally fine. Absolutely valid. Both options are 100% valid ways to go. And neither one of them is better. They're just different. So either way you go through that one is totally fine. I saw a lot more attempts on this factoring problem than on that first one. So what do we get as our factors once we've done this one? What was your answer? Because I saw a lot of people have it. Yeah. We should have gotten x minus 2 and x minus 2. It's actually another way I can write that. Because x minus 2 times x minus 2, well, that's x minus 2 times itself. So this is the exact same thing as if I had x minus 2 squared. And that pattern is actually what we're going to talk about today. When we wind up with the exact same piece here, we can rewrite it like this. And then we can actually use this technique to finish solving it. Like, that's a process that we're going to work with. Mostly we're going to work that whole process after fall break, but we're going to start looking at things right now. Questions on these? Awesome. We are going to be in a workbook. Note packet, not workbook. We're going to be on page 11. And we're just going to do page 11. We are not. No, parent-teacher conferences are tomorrow. Like for the quarter one report card? I don't remember. I was like, anything that was in yesterday should be in now. Except for I have like a test makeup and a retake that was done. Those I have yet to put in. Anything turned in today, I will do my best to get it before parent-teacher conferences. As far as report cards go, they pull that whenever they do. I was like, I try and update grades as quickly as I can, but those will be what they're gonna be. I don't even remember what the cutoff is for it. Oh, they would have pulled those yesterday, I think. Usually they pull grades for report cards on the Tuesday before. It's listed for report cards. Oh no, wait, the quarter doesn't end until Friday, so they won't be due until like we can come back. Quarter ends on Friday. So for report card grades, it'll be the Tuesday after fall break. For parent-teacher conferences, which are tomorrow. Whole other deal. Okay, so we're going to work with a couple of special patterns that are very much like when we had our difference of squares. How when we had our x squared, that was a perfect square, and our 100, that was a perfect square. Very similar vibe. So this is very, very similar. In fact, it also still has our a squared and our b squared. So it's still going to start with a perfect square, and it's going to end with a perfect square. So if we see perfect squares on either end, we should check and see if this middle is the same thing as 2 times the front times the back. Because then what we have is called a perfect square trinomial, and it has its own special pattern, because I could rewrite this in its factored form. It would be our a plus b times a plus b, or a plus b squared. And I know you don't have a ton of space, so I don't want to write it out both ways. If you want to write it down below so that you have it in its factored form as well, that's the same exact thing as if it was a plus b times a plus b. And we're going to know that it's going to have a plus between both of them because this front one is a plus. If I was to re-multiply this out, even right now as it is, I would get exactly this. Because I have my a times a to be a squared, a times b, a times b. So I have 2 ab's and then a b squared. That way. So these two things mean the exact same thing, and they will all multiply up to this. The bottom one is very, very similar, or for you guys, it's the next one over. It's the right one. The only difference is it's a minus right here. So again, it has a perfect square in the front. Again, it has a perfect square in the back. And the middle is twice the front times the back. And it's going to look almost identical, except it's going to have a minus sign. Or I could write this as our a minus b times a minus b. So our difference of squares gets one of each. 1 plus 1 minus. If we have a perfect square trinomial, perfect squares on either end, that's when we're going to have our plus we that term in the middle. That's when we're going to have a matchy. So if we have them both with pluses, that should have 3 terms. If we have both with minuses, it should have 3 terms. We have 1 plus 1 minus, only 2 pieces, only 2 terms. So we're going to work with this on the 4 right below, where we're going to mark the put these into factored form. Is their perfect square trinomials. We are not going to do the bottom part of 11 where it starts with that find the value of c. That'll be what we start with after fall break. So let's look at those bottom 4, and then we may go catch 5, 6, or 7 up at the top if we have time. So here's number 1 right below where we were talking about our perfect square trinomials. So the first thing that I notice is I've got my beautiful perfect square here, x squared, love it. And I see 81. 81 is one of those ones that puts a little flag in my brain. 81 is a perfect square. We know 81. What squared gives me 81? 9. So I could rewrite this as my x squared. Thank you, dear. And I could rewrite this as my 9 squared. Now, if this is a perfect square trinomial, then the middle piece should be made of 2 times the front, that x, times the back, times the 9. What is 2 times x times 9? What does this equal? It equals exactly 18x. Because 2 times x times 9 is the same thing as 2 times 9, 18 times x. So since this follows the pattern, this is a perfect square trinomial. So I don't have to do split the middle or bottoms up or factor by grouping or using the box. I can use the special pattern that we just talked about, where it's very much like our difference of squares, where I'm going to have the x that was in the front be in the front. Our 9 that gets squared is in the back. That's this 9 here. Since we have a plus right here, we're going to have a plus in between them. And we are going to get 2 copies of that. So it's got to be squared. It 100% still works to do this factoring old school, to do this the long way, to use the box, to use the X-frame, to use any of those pieces we talked about before. 100% absolutely works. Sometimes it's nice to save a little time, though, if we can spot it. Questions on this one? Okay. Let's look at number 2. Again, we're just trying to factor these. So if we spot it, great. If we don't spot it, it's totally fine to go another direction. I do see that we've got our x squared out in front. Is 225 a perfect square? I was going to say, it is. It's just not one we typically work with all that much. If you want to see on the calculators where you can find that, I'll show you how to pull that up real quick. Because you can absolutely check and see if something's a perfect square on the calculator. Hit the green button on the top. We hit the square button right here. That gives us our square root. It undoes squares. So the squares undo square roots. 225. I can just type it in. 225 is indeed a perfect square. It is 15 squared. I was going to say, je m'appelle au petit français. No hablo español. The only sentence in Spanish I know is yo quiero Taco Bell. That's it. But 225 is 15 squared. So we have the pieces we suspect. We expect this to hopefully be a perfect square trinomial because 225 is a perfect square. So then what we need to do is, in order to actually use our pattern, we need to make sure that this middle piece should be made up of 2 times the front, which was our x, times the back, which is the 15. Is 2 times x times 15 30x? Yes. The minus sign's okay. The minus sign's okay. Just the values. We don't need to worry about the sign because the sign just tells us what goes between our A and our B. So just the value here. Good question. So this does fit the pattern. I have a perfect square in the front. We had our x that got squared. I have our 15 that got squared in the back, and the middle is made up of twice the front times the back. So I can go and use my special pattern here. We could write this as our x in the front, 15 in the back, and because this has the minus sign right here, we use our minus sign. And it's going to be 2 of them. So it's always going to be squared. So I can rewrite this in this form. Now we don't have to do this pattern. Like if you want to go old school factoring on the whole thing, totally fine. I'll show you that on the next one, that it genuinely is okay if we don't want to work on this, memorizing this pattern. Totally valid. The difference of squares one I do want you to know, because that one is something that's going to come up a bunch, and we're going to use it a billion times. We will use it all year long, the difference of squares. Perfect square trinomials, if we can spot them, great. If we can't, it's not going to be a critical time deal breaker for us. Questions on this one? All right. Let's look at number 3. It does fit the pattern, but I'm going to show you that it's okay if we don't notice that, because we can 100% still use our old school factoring. Because I could just go, sweet, factor. That means I'm going to use my x, where I take my a times c at the top and b goes at the bottom. My a is what? 1. What is my c? 64. So 1 times 64 is going to give me a 64. And my b goes on the bottom, which is negative 16. What is a pair of numbers that multiplies to make 64 and adds to make negative 16? Negative 8 and negative 8. We get the exact same number for both spots. And again, since I don't have an a value, I could use my shortcut where I write it in my parentheses right away. Or I could go through the whole box, or factoring by grouping, or split the middle, or bottoms up, or any of those things that I showed you guys in the videos on Monday. I'm going to do the box here just so we can see it. Our x squared goes in the top left. Our 64 goes in the bottom right. Those go in those spots, non-negotiable. If you're a box person, A and C go in those boxes. Have to. The numbers we picked here get this middle variable. So minus 8x. Minus 8x. It does not matter if I put this minus 8 here, if I put this minus 8 here. These two can swap spots. These two cannot. When we pull our factors in columns and rows, what are we going to get? What are our factors that we're getting here? What's shared between x squared and minus 8x? What do they have in common? Just an x. Absolutely right. What's shared between minus 8x and 64? Negative 8. And then we do the same thing for our rows. Between x squared and minus 8x, hey, wait, we already thought that one. It gives us an x. And our bottom row, between minus 8 and positive 64, again, we've already thought that one. It's again a minus 8. This spot is always going to have the same sign as this box. And this spot is always going to have the same sign as this box. So we could come through and write this in its factored form. Those pieces we found on the outside are our factors. Our x minus 8 and our x minus 8. Absolutely valid. 100% okay. I could also write it as our x minus 8 squared. Either one of these works just fine. There will be times when having it written like this is more helpful. There will be times when having it written like this is more helpful. In particular, when we have the parentheses squared, that's going to really, really help if we're looking for, let's say, a vertex. Because that gets it real close to vertex form. And writing things in vertex form is what we're going to start with when we come back from fall break. So let's take a look at number 4. Because this is a lot of work. It works. It's functional. But that was a lot of stuff. So if we start to notice the pattern, start to say, hey, wait a second, I got a perfect square right there. And I got a perfect square right there. It will save us some work. You don't have to do it, but it's kind of like a shortcut. So I know that's not a pen. I know that I could rewrite x squared as x being squared. What squared gives me 36? 6. This is the same thing as if I had 6 squared. Is the middle term 2 times the front times the back? We need the middle piece to be 2 times the x that's in the front times the 6 that's in the back. Is what we have here in the middle what we would get from this? Yes. Because 2 times x times 6 is 12x. So that means I can use my difference, or my perfect square trinomial pattern. If this is anything different, so if this was, let's say, 13x, I could not use this pattern. My factors would be different. I would have to then go through my old school factoring. So only if it fits this pattern, only if the middle piece is actually made of 2 times the front times the back, can we use our special pattern. And then we absolutely can, since this does work. We have our x that was in the front. We have our 6 that was in the back. And what sign are we going to use in the middle? Plus. And we cannot forget the power, because we get 2 of them. So x plus 6 times x plus 6 would exactly give us x squared plus 12x plus 36. So this is like a little shortcut for us for our factoring in very specific scenarios. But it's very, very specific. We have to have these pieces. Let's do one more from the top of the page just to practice our factoring again. Let's do number 7 at the very, very top of the page. So we're going to be page 11, number 7 at the top. And this will be our last one for today. This is our 6x squared minus 21x plus 15 equals 0. And we are solving. We're going to get all the way down to our x equals. What do we need to do first on this page? Say it again. We're not going to minus the 15. We want it to stay equal to 0. What else could we do? If you need the list, look at the page 10. Halfway down page 10, we've got the list of instructions. See if we got a GCF. Do we have a GCF, a greatest common factor, between 6x squared, 21x, and 15? Is there anything they can all divide by? 3. Every single one of these divides by 3. So I can take out a GCF of 3. So GCF was our first step, and we have one that's 3. When I take that GCF of 3 out, we're left with 2x squared minus 7x plus 5. I divide 3 out of each of these pieces. So we notice that everybody was divisible by 3, so we have our 6x squared divided by 3 gives us 2x squared. Our 21x divided by 3 gives us 7. And our 15 divided by 3 gives us 5. So we've got our GCF out. Remember that 3, that's our obnoxious little line leader, goes and stands at the door 20 minutes too early because he's determined to be the line leader. He's going to stand at the door. We're going to ignore him. He's just there. What can we do for this? Because now what we're going to do is we're going to factor this in some way. You can use the box. We can factor by grouping. You can use bottoms up. There's all kinds of different methods. I gave you 3 or 4 different methods in the videos from Monday. So pick something and factor it. I don't care how you factor, just that you factor. I do care if you don't show work, because then I know you phone factored it. You got to show me something. Or if you've done it all in your head, write out how you did it so that I know you did it, not your phone. Because I'm real suspicious when you just put me down factors. I'm real suspicious. I will be checking a lot more questions if you just write me down answers. And half the time it says show work in the instructions, which means if you don't show work, you don't get points. Just saying. You gotta show the work. So you can do this in whatever method you choose. For pretty much all of them, though, we need to know the values from the x-frame, where we have our a times c, our a being 2, our c being 15. So it's going to multiply to make 10 and add to make our b that negative 7. What pair of numbers will multiply to make 10 and add to make negative 7? Negative 5 and negative 2. That's how this piece splits into the 2 pieces before we combine the like terms. How do you guys want to factor this? Grouping, box, bottoms up? What you got? I can do any of them. Well, what do you like? Yeah, let's do the bottoms up one. So our 3 is just going to sit out in the front. He's just sitting there. When we're setting up bottoms up, we set it up just like we did the shortcut when we don't have an a value. So I'm going to put my x with my minus 5 and my x with my minus 2. But I'm not done on this step, because I also need to come through and put my a value, this 2, as a denominator. So I need to divide this piece by 2, and I divide this piece by 2. This is how we set it up for bottoms up. Then we come through and we need to simplify each of these fractions. Does this simplify? To what? X minus 1. So, and I'm going from the right to the left, but it's a choice. So this becomes x minus 1. Does this simplify? No. 5 over 2 is going to be decimally no matter what. It does not simplify, so any denominator that's left needs to go back up. This is where the bottom goes up. So the reason this is called bottoms up is because I need to take this 2 that's left in our denominator that would not simplify, and it's going to go up there. So we're going to write this as our 2x minus 5. And then our obnoxious little line these are still sitting out front. So we set it up like we had the shortcut. Divide both numbers we've picked by the a. Anything that doesn't simplify goes up to be a coefficient. It's really, really, really important that we remember to do this part. It is not x minus 5x. It is 2x minus 5. There should be no denominators left in your factored form. Once we have it factored, this is as factored as it gets, then we need to find our solutions. We're going to solve. We're going to get to our x equals. We want to find our roots, solutions, zeros, x-intercepts. So that's when we take each of our factors, this guy and this guy, and we set them equal to 0. Anything that has an x in it. So if our GCF had an x in it, that would also count and get us equal 0. So if it has an x in it, it gets set equal to 0 to find a root. So we're going to have our 2x minus 5 set equal to 0. I'm going to scooch the page a little bit just so we're not working at the very, very bottom. And we're going to have our x minus 1 equals 0. Well, this one's a little bit shorter, so I'm going to start over here. What do I do to figure out what x is going to be? Plus 1. If I plus 1 on both sides, we're going to have that x equals 1. So one of our solutions is going to be at the point 1, 0. That's one of our roots, solutions, zeros, x-intercepts. That's one of our guys. For our other one, it's going to take a couple additional steps, but we'll get there. Because what do I need to do over here? Add the 5. We're going to add the 5 to both sides. That's going to give us that 2x equals 5. So how do I figure out what x is? Divide by 2. So our x equals 5 over 2. Absolutely valid. And we could have it as a fraction. We could write our point as 5 halves, comma 0. That's valid. It's not wrong. It's not easy to graph, but it's not wrong. We could switch it to be a decimal and write this as 2.5, 0. That one's probably a little easier to graph. But both of these are equally correct. Either one's totally fine. So this guy and one of these. Only one of them. But one thing that's kind of cool about bottoms up, and we notice we got 5 over 2 here. 5 over 2. This was our root. Here's our 1 right here is coming from this simplifying down to a 1. So our 5 over 2 was exactly what our root was. Our 2 over 2, which was our 1, is what our root was. So bottoms up is kind of cool in the fact that it kind of builds from the roots. So you don't need to have both of these pieces down here. You just need one of them. I don't care how we factor, just that we factor. Just make sure you share how you did it, because I want to know. Okay? Questions on that one? Okie dokie. Artichokes. That's all I got for you today. No, that is not the correct. Today's not the turn and bell work day. We'll turn bell work on Friday. Those numbers are wrong. Those are all from last year stuff. That says November. That's not true. 3-4 is due on Friday. You do have a Canvas assignment that you have to do tomorrow because we have to have a way of marking your attendance. So the weekly Canvas assignment is set to open tomorrow morning so that it counts as your e-learning assignment so that we didn't have extra to do. It's the normal weekly Canvas assignment. Okay? So if you are working on stuff and have questions, please feel free to send me messages, send me emails. I will be here meeting with whatever grown-ups choose to meet with me. So the 3-4 homework is due Friday. And our chapter test is, I want to say that's October. October 24th. So we have a couple minutes until the announcement reminder. So now is a great time to work on 3-4 if you have not finished it yet. Again, work through stuff tomorrow. Let me know if you have questions. I am happy to help anytime you need. That's kind of a vibe.